Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Hanum SALSABILA. I'm from Physics Education 2023, and in this time I would like to tell you the material about gravitation and gravity. So, without further ado, let's talk about it certainly. Gravitation is a force of attraction between any two bodies, while gravity refers to the force of attraction between any body and the Earth. For this material about gravitation and gravity, we have 7 lists or topic that we would explain to you all guys. And for the first list, let's talk about Kepler's laws. There are 3 laws of Kepler's laws. And the first one is law of orbits, the second law is law of areas, and the third law is the law of periods or harmonic law. The first law of Kepler's law is about law of orbits. All planets move in an elliptical orbit with the Sun at one focus. Every planet moves in elliptical orbit around the Sun, with the Sun being at one of the focus. After the first law, let's talk about the second law, that's called law of areas. A line joining any planet that the Sun sweeps out equal areas in equal times. The radius vector drawn from the Sun to the planet sweeps out equal areas in equal interval of time. The aerial velocity of a planet is constant. The first and the second law done. So let's talk about the third law of Kepler's laws, that's called law of periods or harmonic law. The square of the period of any planet is proportional to the cube of the semi-major axis of its orbit. The square of the period of revolution t of a planet around the Sun is proportional to the cube of the semi-major axis r of the ellipse. So that's all the topic from the first one is Kepler's laws. Next, we're gonna talk about Newton's law of gravity. Newton's law of gravity postulates that there is a force of attraction between each pair of point particles that is proportional to the product of the masses of the particles and inversely proportional to the square of the distance separating them. It states that everybody in this universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Let and be the masses of point particles 1 and 2 at position and respectively, and be the position of particle 2 relative to particle 1. The gravitational force exerted by particle 1 and particle 2 is then mathematically F or force is equal to G times masses 1 and times masses 2 divided by R square, where G is the universal gravitational constant. It was derived by Newton on the basis of Kepler's laws of planetary motion. And that's all the explanation of the topic before, that's called Newton's law of gravity. And for the next one, let's talk about measurement of universal gravitational constant G. The universal gravitational constant G was first measured in 1798 by Henry Cavendish. Cavendish measurement of G has been repeated by other experimenters with various improvements and refinements. All measurements of G are difficult because of the extreme weakness of the gravitational attraction. Consequently, the value of G is known today only to about 1 part in 10,000. Although G was one of the first physical constants ever measured, it remains one of the least accurately known. So, that's all the explanation for the measurement of universal gravitational constant G. Next, let's talk about gravitational mass and inertial mass. The mass of a body, which determines the gravitational pull due to Earth acting upon it, is called gravitational mass. On the surface of the Earth, F or force is equal to gmmg divided by r squared. Gravitational mass is mg equals to fr squared divided by gm. Inertial mass of a body is equal to its gravitational mass. And for the mass of a body which measures its inertia and which is given by the ratio of the external force applied on it to the acceleration produced in it along a smooth horizontal surface is called inertial mass. Next, let's talk about escape from Earth or escape velocity. If the initial kinetic energy is greater than the object is said to escape from Earth, because the potential energy at Earth's surface is the total energy must be greater than or equal to zero in order for the object to escape Earth. It is the minimum velocity with which a body must be projected vertically upward in order that it may just escape the gravitational field of the Earth. For Earth, the value of escape velocity is 11.2 km second. It is independent of the mass of body projected. Okay, for the next one, let's talk about gravitational potential energy. Near the surface of Earth, the gravitational force exerted by Earth on an object is essentially uniform because the distance to the center of Earth is always approximately for the potential energy of an object near Earth's surface is where we have chosen at Earth's surface as R equals to RE. The gravitational potential energy of a body may be defined as the energy associated with it due to its position in the gravitational field of another body, and it's measured by the amount of work done is in bringing a body from infinity to a given point in the gravitational field of the other body. Classification of orbits by energy. The potential energy of an object such as a planet or comet or mass m at a distance r from the sun is U equals to gm m divided by r. To summarize, when the total energy is zero or positive, the object is not bound to the sun but will escape. Curiously, there have not been any measurements of the energy E of a comet or an asteroid. They are definitely non-negative. Thus, all observed comets and asteroids appear to be bound to the solar system. Next, let's talk about gravitational field. We will show that the gravitational field due to the shell at distance r from the center of the shell is given by because the field due to each shell is the same as if its mass were concentrated at the center of the shell. The field due to the entire sphere is the same as if the entire mass of the sphere were constructed at its center. For a uniform sphere, the fraction of the total mass of the sphere within radius r is equal to the ratio of the volume of sphere of radius r to that of a sphere of radius r. Thus, if m is the total mass of the sphere is given by the gravitational field at the distance r is this, or